properly. So there is a transparent insulating cap between each set of elements to permit the passage of light. So they are designed with a very small response time such a way that they can transmit huge amount of data. So the light coming out of LED will pass through a small passage which is connected to the photodetector just to avoid leakage of light through any other means. So whatever light is being emitted from the LED is going to be fully coupled to your detector so that you are going to have maximum efficiency. So the rigid structure permits only one-way transfer of the electric signal, and you cannot have any backward communication. So this circuit works only in this way. It will not work in the reverse way. So it will not work in the reverse way. It will work only in the forward way. In the output, if I give electrical signal to detector, it will not work because detector will work only with light, and that light has to come only from LED. So this circuit will work only in the forward direction. If you connect the same thing in the backward direction, this circuit will not work because it is an optocoupler, or I can say it is an opto-isolator. So isolator nale, it will permit only one way of communication. The reverse communication is going to be not permitted. Okay, so that is what they're saying. It permits only one-way transfer of electrical signal from the LED to the detector. So the reverse connection from detector to LED is not permitted because the device is an opto isolator. It will not work in the reverse way. So how much isolation I'm going to have, it will depend on what kind of material I'm going to use in the light path and the distance between the source and detector. So if the distance is very less, then coupling is perfect. The distance is somewhat larger, then the coupling might be reduced. It will be reduced because the signal has to travel a longer amount of distance and fall on the detector, right? So that's what they're saying. So how much amount of isolation you require, it depends on two things. One is what material I am going to have inside the light path. Second thing, how much distance I'll be having the between the source and the receiver, because the light has to travel that much amount of distance in a finite amount of time. So a significant advantage of optocoupler is provides very high isolation, 10 power 11 ohms isolation. That reverse current flow ஆகாது. When the resistance is very high, the current is almost zero. So it provides isolation up to 2500 volts between input and output signals. So that is why these optocouplers are used in high voltage systems for providing even up to 2500 volts of input and output stages. You can isolate them properly using optocouplers. And since it provides a very large resistance, the reverse current which is flowing to the device is going to be almost zero. So these devices can be used in different types of logic circuits and level positioning circuits. So in the opto isolator, the power dissipation of LED are almost equal, and it is measured in nanoamperes. So the operating temperature will vary from 25 to 75 degrees Celsius. So the VC voltage affect the resulting collector current only very slightly. So what they are saying is, instead of having a photodiode, I can use a phototransistor, because the phototransistor will have almost dark current is going to be very, very minimum in the order of nanoamperes. That is one advantage. Second, the temperature variation is very, very minimum. They say the output current is almost constant even when the temperature is varying from 25 to 75 degrees Celsius. So the current variation is also minimum. And last thing, the voltage variation is also going to minimum, and it is not going to affect my circuit. So wherever you are going to use these detectors, what they say is, instead of using photo detectors, you can use photo transistors. Don't go for photodiode. You can go for photo transistors because they amplify the signal, and these 3 points are favoring your photo transistors. One is zero dark current. Second one is the constant current even though temperature is increasing from 25 to 75 degrees Celsius. And last one, even though voltage is varying, the current is not going to vary. The current is going to be almost constant. So this is going to be an optocoupler using photodiode. This is an optocoupler using phototransistor, and this one is optocoupler using light activated SCR, LASCR. And transistors, even if one transistor is not enough, you can connect two transistors like this. This connection is called as Darlington connection. Darlington pair nu solluvaanga. Darlington pair means you are going to connect the emitter of one transistor to the base of the second transistor. Okay, and the output you take from the second emitter. This is called as Darlington pair. All the collectors will be shorted, and input is given. You are just forwarding the input from one transistor to another transistor. Here the input is given to base, output taken from collector, emitter. This output from emitter will be serving as input to the base of the next transistor, and output I take from the emitter. So when you connect transistors in this way, it is called as Darlington pair. See the name, it is given photo Darlington. It is normal Darlington when you are going to use normal transistor. Since it is going to be a photo transistor, I am going to use the name photo Darlington pair. Third one is SCR, light activated SCR. So the optocoupler is going to be turning on very fast when you are going to increase the amount of current. So it is, if you, the turn on time is only 2 microseconds for a collector current of 6 milliamperes. So it can turn on as quickly as 2 microseconds. It will take only 2 microseconds to turn on the device. And the schematic diagram is shown to you of optocoupler. So either you can have three configurations are possible. Either I can have optocoupler based on photodiode, or I can have an optocoupler based on Darlington pair, or I can have an optocoupler based on light activated SCR. See, whenever I'll just say the purpose where optocouplers are used. Whenever there is a requirement that some parts of circuits need to be isolated, when same electrical current or voltage is going to be flowing to the device, then isolation is not possible. But when you introduce a circuit where the conversion of signal is going to be from electrical to optical and then optical back to electrical, there I'm going to have an isolation being done. So that is what is happening here. So in this circuit, between the input and output, I need isolation. So I'm going to insert a device called as optocoupler. The inside on optocoupler, what you have the mechanism to convert from electrical energy to light, and light back to electrical energy. So in these applications, I'm going to use optocouplers. And see, in optocoupler, the source is always LED or laser. Sometimes I can replace LED with laser, but the detector, I have three options. I can go for photodiode or photo transistor using Darlington pair, or I'm going to use light activated SCRs. Okay, so this is going to be the features of optocouplers. So optocouplers have a lot of applications, isolating different parts of your circuit.